Hello students, welcome back to my channel. In this video, I am going to solve this question from oscillation topic for you. This question has been sent to me by one of the students who is preparing for JEE mains and advanced exam. So in that he is having a trouble with this question. He know the answer of this question, but he don't know exact the way to solve it. What is the thinking required for this type of a question, he don't know. So this question is going to be for JEE students particularly. Such questions don't come in the NEET exam. But for knowledge point of view, even the NEET students can see this video. Okay, so we are going to solve this one problem of JEE level in this video. Okay, look at this diagram very carefully. This M block is slightly displaced and left. Suppose if I take this M block downward and leave it, you can visualize that this M block will oscillate. So we have to find out time period of this oscillation. Okay. These two springs, K1, K2, these springs are massless, even pulley is massless, string is also massless. Here one string is there, right? This one. Even the string is massless. So let's see how to approach such questions. In this question, suppose if I take this M block downward by X distance. If I take it downward by X distance, imagine if I pull it by X distance. Then you can visualize that even pulley will be shifted downward. Let us suppose pulley shift down by x1 meters. If the pulley shift down by x1 meters, the upper spring will also stretch by x1 meter. Let us suppose pulley and upper spring stretches down by x1 meter. And this second spring, K2 spring will also stretch. Let's say it stretches by x2 meters. Okay. So x1, x2 and here x I have taken. First of all, we have to find out the relation between these three. To find out the relation, okay, this simple diagram I am giving you, see carefully. Okay, this is suppose original diagram, like this. Okay, originally suppose this was a situation. Okay, now this pulley has gone down by x1 meters. Okay, so this is x1. If the pulley goes down by x1 meters now, then the string will become this way. Okay, from this side x1 meters and from this side x1 meter, the string will be shifted this side. So you can understand that this block should go down by 2x1 meters. First understand this. If pulley goes down by x1 meters, the string from this side and string from this side, x1 and this x1, that is 2x1. That 2x1, that string will shifted on this side. So the block will go down by 2x1. Also now see this spring. So this spring stretches by x2. Because this spring stretches by x2, so here the length of spring will increase by x2. So because of that, string will shift here on the right side by x2. So overall the displacement of this block should be 2x1 plus x2. Understand this, It is only the difficult part to imagine. So, but here you have written the displacement of the block as x, right? So this x will be equal to 2x1 plus x2. Okay, this is the thing. So displacement of the block x will be 2x1 plus x2. Okay, let's give it first equation and leave it. Okay, now we have to just see the tension in the strings and all. See, if you know that in the string tension will be there this way, T. Okay, this way also T. Same T will act on the pulley also, like this. Okay, and upward force on the pulley will be K1 X1, and here downward force on this string will be K2 X2. Okay, see the diagram carefully. Okay, so now this pulley is considered to be massless, right? So pulley is massless, so downward force on the pulley will be equal to upward force. So downward force is T and T on the pulley, that is 2T. 2T is the downward force on the pulley, upward force is K1 X1. So I can take these two equal. And for this spring, on this spring the upward force is T, downward force will be K2 X2. So I can also write down as T equal to K2 X2. Okay, these equations I can write. From this one, you find out the value of x1, x2, and that way we will put it here. Find out x1, x2 from this, put it here. So x will be equal to 2, x1 will be 2t by k1, and x2 will be T upon K2, right? Okay, so you can take T outside. Okay, T equal to 4 divided by K1 plus 1 upon K2. Just solve it and get the T from this. The T will be equal to, solve it properly, it will be K1 into K2 divided by 4 K2 plus K1 into X. This, just rearrange the term, you will get this thing. Okay. Now, always in such problem, you should find the T, tension in the string. Why we are doing all this? See, come to this. Now, suppose this block you shifted downward by X meter. You stretch it downward by X meter. So, in the string, a tension developed T. Because of this T force only, this block oscillates. This block oscillates due to T force only. So, this T acts as a restoring force in the spring. Okay. So, in SHM, you know that a restoring force is there, which is equal to Kx. Without restoring force, oscillations never starts. So, this restoring force is here played by T. T is playing the role of restoring force, and X is in the place of X. So, K of this motion is this one. So, you can say that effective K of this motion is this much. K1 into K2 divided by 4 K2 plus K1. Once we got K, then the problem become extremely simple, nothing here. Divide both sides by mass of the body. Divide both sides by mass, like this. It's a mass of the block. Now, K by M it is coming. All of you know that K by M is nothing but actually omega square. The omega square we got from omega square, we can take root on both sides. The omega will be root of K1 K2 divided by 4 K2 plus K1 M. This omega you can write down as a 2 pi upon T. The time period you will get ultimately from this. Time period will come 2 pi under root of M 4 K2 plus K1 divided by K1 K2. So this is going to be your answer for this question. Solving this, you will get this. So I hope students, those who are watching, it's clear. I am solving this from JEE point of view. I hope you are preparing for JEE, then only you do this. Otherwise for NEET it is not required. Okay, we'll meet in the next video now.